Hi class, in this video we cover page 4 of your note packet on section 5.2, graphing polar equations. So we're working the last two examples in this video, and here we're going to graph the polar equation r is equal to 2 times cosine theta, 2 cosine theta. Well, you got to be able to convert to x's and y's, right? Convert from r's and thetas to x's and y's. Well, if we multiply both sides of this equation by r, we have r times r on the left is equal to r times 2 cosine theta on the right. Well, r times r is r squared, and then r times 2 can be written as 2 times r. Order of multiplication can be switched. And so on the left, right, we know that r squared is equal to x squared plus y squared. So I replace r squared with x squared plus y squared. And on the right, r cosine theta is equal to x. So I have 2 times x on the right. So now we have an equation in rectangular coordinates, just in terms of x and y. There are no r's and there are no thetas. But what's this the equation of? Okay. Well, we can subtract 2x from both sides, and we have x squared minus 2x plus y squared is equal to 0. And now I can add 1 to both sides, so that I have x squared minus 2x plus 1 plus y squared is equal to 0 plus 1, which is 1, right? So here I subtract 2x from both sides, here I add 1 to both sides. Well, x squared minus 2x plus 1 factors into x minus 1 squared, right? X squared minus 2x plus 1 factors into x minus 1 squared. And then we have plus y squared, and that's equal to 1. Well, you may recognize this is the equation of a circle, right? Similar to x squared plus y squared on the left, except x is replaced with x minus 1. And r squared is equal to 1 squared. So this is the equation of a circle. Its center, though, is not at the origin, 0, 0. It's at the point 1, 0 on the x-axis. The center is at the point 1, 0 on the x-axis. And since r squared is equal to 1 squared, the radius is equal to 1. So to graph this polar equation, which is the equation of a circle, right, we graph the corresponding equation in rectangular coordinates on a coordinate plane superimposed on the polar grid. And then when we raise the x and y axis, we know what the graph of the polar equation looks like on the polar grid. So the center, okay, is at the point 1, 0 on the x-axis. So I'm going to use the distance between each concentric circle as a half unit. So starting here's the origin at the center. So I got to go out 2 circles to the right. And that's the point 1, 0 on the x-axis. That's where the center is located at. And then the center, or the radius of the circle, is 1 unit. So here's the center. So I got to go 2 circles to the right of it to get the right edge of the circle. And then here's the center. I got to go 2 circles to the left to get the left edge. But the left edge goes through the pole, right, or through the origin. And I can't go up 2 circles and I can't go down 2 circles. So I got to fit this, the graph of this circle with a radius of 1 the best I can by hand, going through these 2 points. And so that's my circle of radius 1, okay? And its center is at the point 1, 0 on the x-axis. So now to get the graph in just the polar grid, I gotta manage to erase the x and y axis. Actually, I can erase the center of it. And there is the graph of r equals 2 cosine theta in a polar grid. So r equals 2 cosine theta, okay, on a polar grid. So this guy up here, r equals 2 cosine theta, is the equation of a circle. And that circle has a radius of 1 unit, okay? All right, lastly, we're going to graph the equation r equals minus 4 sine theta. And we're going to show that that is also the equation of a circle. But its center is located in a different spot. So again, I'm going to multiply both sides of this equation by r. I have r times r is equal to r times minus 4 sine theta. Well, r squared is, or r times r is r squared. And then r times minus 4 is the same as minus 4 times r. I can switch the order of multiplication. Well, r squared is equal to x squared plus y squared. And r sine theta is equal to y. And now, in showing that this is the equation of a circle, right, we can add 4y to both sides. So we have x squared plus y squared plus 4y is equal to 0. And now I can add I can add 4 to both sides. I have x squared plus y squared plus 4y plus 4 on the left is equal to 0 plus 4 on the right, okay? So I added 4y to both sides from going from here to here, and now if we're going from here to here, I'm adding 4 to both sides. Well, y squared plus 4y plus 4, it factors. It factors into y plus 2 quantity squared. Y plus 2 squared is equal to y squared plus 4y plus 4. And that's equal to 4 on the right, which is the same as 2 squared. Well, hopefully from your algebra days, you can recognize that this is the equation of a circle. But the center is not at the origin, 0, 0. That's the equation of circle, but the center is at 0, minus 2. The center is at the point 0, minus 2 in the coordinate plane, which is on the negative y-axis. And r squared is equal to 4, which means r is equal to 2. And so the radius of this circle is 2 units. So to graph this circle, again, we impose a coordinate plane on top of the polar grid with the origin at the pole. And so first we got to plot the center, which is 0, minus 2. So if I'm using, if the distance between concentric circles is 1/2 unit, right? Then I gotta go down, so here's a 1 unit, here's 2 units, right? Gotta go down 4 circles from the pole, and that's the center, 0 minus 2. The radius of my circle is 2 units. So to get to the bottom edge of the circle, I gotta go down 4 circles from the center, 1, 2, 3, 4. So this is the bottom of the circle, bottom point of the circle. And then to get to the top of the circle, I gotta go up 1, 2, 3, 4 circles, which puts the top of the circle at the pole. Okay. Now I can't go to the right 4 circles, I can't go to the left 4 circles, so I gotta do the best I can to draw this circle through those points, those 2 points here. And so hopefully it's something like this on the right half, and something like that on the left hand. That's not symmetric. I'm doing the best I can with what limited artistic skills I have. But the circle looks something like that, okay? But the center is definitely in the correct position. The top and the bottom are definitely in the correct position. Just trying to get it perfectly round is a bit challenging, okay? So R equals minus 4 sine theta is the equation of a circle. Okay? Now we erase the X and Y axis of our coordinate plane best we can without erasing anything. And so this is the graph of R equals minus 4 sine theta. Okay? It's the equation of a circle, and the center of the circle, right, is on this ray 270 degrees, 4 units down from the pole. Okay? And the radius of the circle is 2 units.